Okay, I hope I'm audible to all my students who are attending this particular lecture for the Introductory Mathematical Methods for Economics course. In this particular lecture, I'm going to continue with the discussion of the 2024-25 question paper, which has come up at Delhi University for the Mathematical Methods for Economics course at the introductory level. Okay, and this lecture is recommended for all those students who are pursuing BA Honors Economics from University of Delhi. Okay, I hope all students can see the question paper on your screen. This is the question paper for January 2025. Okay, so all students, you can clearly recall from my previous lecture that I had solved question number 1 completely in the previous lecture. Question number 1 had two parts, A and B, which we had solved in the previous lecture. Now, in this particular lecture, I'm going to start with the discussion of question number 2. So, let's quickly start with the discussion of question number 2 in this particular lecture. So, question number 2, part A, there's a misprint, so we are not going to solve this question. Okay, the question itself is a bit wrong, so not going to solve this particular question. Okay, so I can write this part is not to be done. The original, this is the original question paper and there was a misprint in it, so this is not to be done. And students who attempted this question, even if you attempted it, you would get complete marks. This was for 5 marks, you get complete 5 marks. Okay, we are going to solve part B. Is the statement 3x tending to 7 as x tending to 1 true? Okay, using the epsilon delta definition of limits, justify your answer. Okay, so first of all, students should be able to recall from my lectures on single variable differentiation when we did limits. Remember the epsilon delta definition of limits. So let's quickly come to the whiteboard and revise that. I'm just writing the main heading for completeness. This is Delhi University exam 2024-5. Name of the course is Introductory Mathematical Methods for Economics. This course is recommended for all those students who are pursuing BA Honors Economics from University of Delhi. Okay, so let's look at question 2, part B. Recall the epsilon delta definition of limits, which is as follows. So, limit as x tends to a, f of x is equal to capital A, provided for all epsilon greater than 0, there exists a number delta greater than 0 such that the difference between f of x and its limit value in absolute terms is less than epsilon whenever the difference between x and a in absolute terms is more than 0 but less than delta, where epsilon and delta are small numbers. Okay, so I'm repeating the epsilon delta definition again. When I say that as x tends to small a, f of x tends to capital A, what does it mean in epsilon delta terms? It means that for any small number epsilon greater than 0, there exists another number delta greater than 0 such that the gap between the absolute, when I say absolute, it means modulus. The absolute gap between f of x and its limiting value is less than epsilon whenever the absolute gap between x and a is less than delta. And because it's absolute, it's always greater than 0. Remember, modulus is always positive. And I can write here properly whenever. That means what I'm trying to say is, as x is tending to a, when I say that x tends to a, it means the gap between them is very small, lying between 0 and delta. Then f of x will tend to capital A. That means the gap between f of x and capital A will also be less than epsilon, where epsilon is a very small number, close to 0. Epsilon is a small number close to 0. It means as the gap between x and a shrinks in absolute terms, the gap between f of x and capital A also shrinks in absolute terms. So I hope students have understanding that. So now we need to see that whether it's happening for this. So in the question we were given that as x tends to 1, 3 of x tends to 7. Is it true? This is what we need to check using the epsilon delta method. Okay, so let us choose a small value of epsilon. And then we need to see what will be the value of delta for it. So let's suppose we choose epsilon equal to, let's say, 0.5. You can see that 0.5 is greater than 0. I have chosen a value of epsilon. So let f of x minus a be less than epsilon, which implies, what is f of x, guys? F of x is 3x. A is 7. Epsilon is 0.5. Now remember from my lectures on absolute values and inequalities, okay, how can I solve this inequality? If I erase the initial portion off, I can write this on the top. Recall from my lectures on absolute value and inequalities. Recall from my lectures on absolute value and inequalities. That if x minus a, if mod of x minus a is less than b, it means x minus a lies between minus b and plus b. Similarly, if mod of 3x minus 7 is less than 0.5, it implies 3x minus 7 will lie between minus 0.5 and 0.5, which implies 3x will lie between what? Minus 0.5 plus 7, 0.5 plus 7, which implies 3x lies between 6.5 and 7.5, which implies x lies between what? If I solve this further, x lies between, divide both sides by 3, guys. X 6.5 by 3 is 2.16. 7.5 by 3 is 2.5. So x lies between 2.16 and 2.5. Now what should happen? It should satisfy this, that x minus a in absolute terms lies between 0 and delta. Now obviously the mod will always be positive. I need to check whether mod of x minus a is less than delta or not. So for that, let me erase the initial portion off and let us check whether the second inequality is satisfying. Now x minus a in absolute terms should be less than delta, which implies x minus, what is a? What is small a? Small a is 1, right? Should be less than delta, which implies x should lie between minus delta and plus delta using the inequality rule. If mod of x minus 1 is less than delta, it means x minus 1 should lie between minus and plus delta, which implies adding 1 to every side, 1 minus delta less than x less than 1 plus delta. This is what I get. Let's call it as equation number 2. And at the bottom, you have equation number 1. So now I can erase all this off. Now I can erase all this off and let's compare 1 and 2. From equation 1, 2.16 less than x less than 2.5. This was equation number 1. From equation 2, 1 minus delta less than x less than 1 plus delta. Comparing 1 and 2, what do we get? Comparing equations 1 and 2, I get 1 minus delta equal to 2.16. 1 minus delta equal to 2.16. So what is delta? 1 minus 2.16, which is going to be how much? How much is 1 minus 2.16? Comes out as minus 1.16, which is negative, which is not possible. Delta has to be positive, right? Delta can't be negative. So I can write, but delta has to be positive according to the epsilon delta definition. According to the epsilon delta definition, delta should be positive. So what do we learn? So I can say that therefore, as x tends to a, as x tends to 1, in the question we were given as x tends to 1, 3x tends to 7 is false. It's not true. I'm revising how we have solved it again. We use the epsilon delta method. I just took a value of epsilon greater than 0. I took it as 0.5. I use the fact that absolute value of f of x minus a should be less than epsilon. F of x was 3x. A was capital A was 7. Mod of 3x minus 7 less than epsilon is 0.5. I solve this inequality using the rules of inequality I've covered up in my module on the absolute value and inequalities. I get x lying between 2.16 and 2.15. The second part of the epsilon delta method is that absolute value of x minus a should be more than 0 and less than delta. Obviously, it will be more than 0 because absolute value is always positive. I need to check out the second part, that mod of x minus a should be less than delta. Now, what is a? Small a is 1. So, mod of x minus 1 less than delta means x minus 1 lies between minus and plus delta. I solve this, I get this. This is equation number 2. When I compare 1 and 2, I get 2.16 equal to 1 minus delta and 2.5 equal to 1 plus delta. So when I solve this further, I see that my delta is coming out as negative, which is not possible because according to the epsilon delta definition, delta should be a positive number. Because the definition is violated, we say that the statement as x tends to 1, 3x tends to 7 is a false statement. So hoping all students have understood this. So this is where I stop in this lecture. In the next lecture, I'm going to start with the discussion of question number 3. This is something I intend to solve in the next lecture. So I stop in this lecture. I hope students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.